Good morning, everybody. How's everyone doing this morning?
Pretty good. Accounted for.
Yep.
I did come to the school today to find a sensor, so I'm working on my poster.
Oh, okay. What sensor did you end up picking?
The ultrasonic rangefinder.
That's a good one. Yep. Yeah. Great. So we mostly got our new people here today. David, he was teaching a class last year. Um, he's um he's also pretty experienced with robotics. So if any of you guys have any questions about what the class is like, David would definitely be a good person to talk to. Um, we'll probably wait about until 8:05 to really get this meeting started. I am going to give everyone a sign-in word too, but I'm going to wait until more people are on, and I'll post the link to that in the chat as well for those that need it. So June 10th. So we'll probably have a bunch of people hopping on soon. By the way, David, did Vanessa send out like a separate link for the advanced robotics, or was it just all robotics? Like, did you just get like the one link? Like,
So she just sent me the one link. Basically, she said, oh, I don't remember seeing any other extra link for
an
advanced
advanced
robotics.
session?
Yeah.
Okay. Well, I didn't get one either, so that's
Okay.
that's why I was wondering if we were just lumping it all together. So
I guess.
yeah, so you're going to be teaching the advanced class next year, but as we mentioned before in the emails, the advanced class is a little more free form.
Okay.
It's mainly meant to be a competition robotics class. So,
Yeah.
like for instance, last year with the advanced students, we what we did was we kind of like learn how to do on shape so that we could teach the kids on shape. We what all did we do in the class? Like we went through the current year's rule book and put together like a test for it, to kind of test the kids on, and we went over like more things like about maybe engineering notebook, and talked about a few advanced topics like pneumatics and odometry and things like that. But a lot of that is basically you kind of come up with what you think that might need, like what kind of skills that might need for a robotics team, and just kind of
Right.
like make a unit out of that. Like you
Okay.
can, yeah. But it's pretty free form. It doesn't have like a set, because like originally there wasn't anything in the class. Like back when I took the advanced class, it was nothing at all. It was just like, okay, well, really just use this time to let your kids work on their robots and
Okay.
their competition robots. And yeah, so you could kind of just push it in that direction. Yeah.
Okay. That was kind of what I was hoping for.
Yeah.
Because I really want to get the robotics team back going at the school, and that the students basically told me if we don't have a class for it, they
They're
weren't
not
going to
going to
be
come
able
after
to
school.
really, yeah, they weren't going to really be able to do it otherwise because they have jobs and stuff. So, so that was my kind of pitch to getting it running anyway. So, and I'm hoping that I've got a quote put together with Vex that hopefully we'll be able to get the game pieces and the a pneumatics kit before school starts, so that whenever we start up school, we'll be able to kind of hit the ground running.
Mhm.
At my school we have like this weird block schedule thing where it's like on 4 of the days we have 90-minute classes, but one day a week we have a 45-minute class. So what I was
That's
gonna
weird.
do, yeah, yeah. Uh, so on Wednesdays we see all of our students, but it's a really short class. It's 45 minutes. So what I was thinking I might do is try to make it to where on the short days, on those Wednesdays, will be instructional days. And then on
Okay.
the long days, we'll be like, okay, guys, these are times for committee meetings and build time and work time to try to advance the team. So
Mm-hmm. Yep. Yeah, that sounds good. Um, yeah, I would definitely like. I would probably, if you're trying to put any structure to it, like, you know, just the things they need, like, like maybe like early on, just like developing a drivetrain, and you can maybe have them research different trains, things like that. Just the general stuff, and then later on, you can get into more like sensors and PID control or something like that. But just kind of maybe hit topics as they need it. Of course, um, the season's so early, right? Well, not really early, but it's kind of in the middle of the year. So they kind of have to have a robot usually by November to start kind of competing with. So that's going to be a big push. I see a lot
yeah,
more people are hopping. Mhm. Yep. We're probably going to get started with the meeting around 8:05, where everyone is just joining us. I'm just giving everyone a little more time to hop on. So while we're waiting to get started, anyone want to share anything that's going on with them that they're excited about?
I'll go ahead and share. Keno Turner, I'm at New Orleans Science and Math High School. Last year was my first year teaching robotics, which it ended up being pretty great. Now that I have an understanding of how the competition schedule goes, because our classes are 90 minutes and we go by semester. So having to take a year-long course and condense it into 16 to 18 weeks, it was a little challenging. However, we were able to get it done. So the biggest challenge for us was really understanding the rigor, because in the past, our robotics, it was a robotics club. So they could show up only 2 days out of the week for a few hours. And they were in the first robot competition and not the VEX. I like the VEX way better than the first robot competition. But what it did is it allowed me to use the research. If any of y'all know about CPERCH, which is sponsored by the U.S. Navy, they really like, so having both of those things going on at the same time, it was great because now they could really see it. It worked out well enough to where we placed third at state in the state fair competition, which had never happened before. And they used our robot to deliver a diploma at our graduation. We had a student who had passed away of cancer, and they used the robot to deliver that diploma to the family. So that was real great. So I'm excited about how it's gonna kick off this year. Especially knowing how it all works. So And they had me scheduled where I was going to go to the VEX conference that was in Dallas, but that was the same week that we had leak testing. So, which I knew good morning, that I should have been able to get some updated information as to how some of the competitions were going to go. But all in all, it was pretty good. The understanding gear ratios was another thing, just because I had a lot of sophomores in my class. So having that different level of math skill, it started out as a challenge, but having taught math for over 25 years, I was able to get them on board with how it works, but really understanding the rigor. And that equipment is expensive, so you can't be playing as randomly, dropping screws here and there, because all those things cost. So,
yeah. Well, I'm glad you had a good experience with the program. And so, did you teach at the? I'm trying to remember. Was it fall quarter or was it spring quarter? I think you had it
so
spring,
how
right?
how it worked was we had intro and advanced all in the same class.
Mhm.
So in the fall, it was intro to robotics. Then in the spring, I was able to select like 8 students who rolled over to the advanced class. And what I did was I used those as my group leaders to help the intro kids put together the instruction manual, put together the Google slide presentations, so because they had just done it the semester before. So I leaned on them to kind of like lead those lessons for me.
Oh, well, yeah, that's awesome. Okay, so it is about 8:05 right now. So what I'm going to do, I'm going to post a link in the chat. Let me grab that link real quick. And it's just for a Google form for a sign-in, just so that we can have a record of who all showed up. And it's kind of like, it's just basically the same sign-in that we use for the classes. And it's going to ask you for a word of the day, and today's word is going to be refresher, because we're doing a refresher today. And so there's not actually a whole lot of new changes to really kind of talk about this year. So what we'll probably do is just kind of share a lot of our experiences today. We won't keep everyone on too long today. I think I heard like how many of you guys were in the intro to engineering meeting yesterday? I think a few of you were. I heard that meeting only kind of lasted around 2 hours. It looks like we have a few more people popping on. So let me share that again in the chat for people just joining us. So so it went from 2 to noon for dual enrollment, 2 to non. Oh, 2 for non-D. Okay, yeah, that's right. About 2 hours. So once again, in the chat, that's the link to the sign-in, and the word for today is going to be refresher. So for those of you just joining us, just click that link and type in refresher, and we can keep track. And there's Lawrence. I'll post it. I want to be posting it a few times because every time, when you log in, you don't see the past stuff in the chat. So once again, that's the link to the refresher. The sign in for the refresher, and the word for today is refresher. So
I do have a question, Mr. Eric.
Sure.
So the rest of Wednesday, Thursday, Friday, I guess the rest of the class, will I need to be in my classroom? Because I think they're about to start waxing. Or
Oh,
can I do
okay.
it at home? Or what would I need to do it at?
To bring with you. So you definitely want a robot, and you probably want to grab. So grab that ultrasonic sensor, that rangefinder with you. Um, if you have a vision sensor or a well, just I would just grab any sensors you can find because we can
I
probably
do have a box. I can just bring the box.
yeah. And then also you want to bring some wires to connect those sensors to. And I would always recommend bringing an extra battery and a charger.
Yeah.
Just your typical things for your robot. But we won't necessarily, and maybe bring, some screws and nuts to mount those sensors with.
Okay.
Um, but we're not going to do. We probably won't need to do any major modifications to the robot for the rest of the class. So
If
I
we
wouldn't worry.
detached our arm just to make it easier to mess with the drivetrain, should we put that back on?
No, that won't be. No, you won't need to worry about that because for instance, for like the Roomba project, that arm will probably get in the way of hitting any buttons or anything or bumpers on the front. So you might as well just leave it off. It'll be fine. Yep. Okay. So we have quite a few people joining us today. As far as first, let's get away any changes, and there's really haven't been any changes this year, but we will be seeing some changes to the class next year. Well, not this current year, but the next year, because LSU is rolling out their own learning management system for all their pathway courses. And they weren't able to migrate the material over for robotics for the coming year yet. I think we're focusing on just engineering classes this year. But by next year, all that material should be kind of migrated to their own learning management system. So and from what I've heard about it, I haven't really seen it in action yet. But like for instance, students will be able to submit all their assignments in there. They'll be able to turn in their code onto it, and pretty much everything can be done through that learning management platform. It's like an in-house platform developed by LSU, so they have like full control over it. And so we'll see that kind of moving on for the next year, and we'll probably do some updates with everything. But other than that, I'm trying to think of what other kind of changes. I know with Vex itself, like for instance, the programming. If you use Chromebooks, the app, the programming app for the Chromebooks is no longer supported. Now everything is done strictly through the browser. So strictly through just going to Vex Vex code or code v5.vex.com. And that is kind of like their recommended platform for their coding. So it's all going to just be done through the browser. So they will no longer be supporting if you were using like the Chrome app from the web store. If you were using Chromebooks, so now the kids will just go to the website. What other kind of changes? I can't really think of too much. So let's see what I exclusively used browser on the Chromebooks, worked fine. Yeah, and I did too. David, and yeah, and the browser works fine. I think the only slight difference was there was an issue where it wasn't allowing you to connect, but they fixed it. That when they wrote an update at some point. But it used to be you couldn't like connect through your joystick to the robots when you were using the browser, but now you can. And really, the only difference between the browser and the app was the app would automatically detect when you were plugged in to the robot or the joystick. Like it would like as soon as you plugged it in, it would turn green. And when you're using the browser, you have to actually like click to connect, and then pick what port, and then it'll be connected. So it's like, but that's just like a small minor issue, and I think everything else is fine. And I guess one nice thing about the browser is if they roll out updates, they happen right away. So so that's always good. Otherwise, there's as always, there's a new game. I don't know how many of you guys have seen the new VRC game yet. It's interesting. There's a lot of small objects. It almost, in a lot of ways, it almost looks like an IQ game to me in a way, just because like the size of the objects that you're using are very similar to the size of IQ objects in the past. But I've already seen online, like in Asia, they've had like competitions already, like scrimmages and stuff. So there's already a lot of teams like building robots already. Our team hasn't really started building anything yet because our school has been waxing the floors, but I just got word that they finished all the waxing in our building. So we'll probably get in there. Probably, I think we're scheduled to go in there like Friday this week. Our teams want to do some stuff. I don't know how far they'll get. But so some teams have already started their summer building. But as far as other changes, not really a whole lot. They've pretty much completely phased out the old vision sensor. I mean, you can still program with it if you have them, but you can't really buy them anymore. So that's probably something we'll have to kind of look at with like Unit 11 was about the vision sensor. And although it was an optional unit, there is the new AI vision sensor, which is just superior to the old one. But we probably need to update that unit a bit for the AI vision sensor. And it would be kind of neat to have like some activities that involve like the April tags, for instance. I think would be kind of cool as an activity. But since that's an optional unit, I don't think there was like a lot of priority on updating that unit. We probably should do something about that.
If we do update it, I would ask that we leave the old material there because a lot of us still have the inventory of the old sensors.
Yes, and just because they're phased out doesn't mean that it can't be used. I will say like the calibrating the colors for the new one is a lot better than the old one, and the interface of connecting it's a little better with the new one as well. So, but yeah, I agree. We should leave the old stuff because I mean, those old sensors were what, $80 sensors, and probably a lot of you guys have a classroom set of them. So it would be a shame not to use them still, for sure. And they still work. So, so one thing I kind of like us to do to start off. First off, did everyone get the link to sign in, or did anyone join us and not have the link to sign in? Okay, so I don't hear anyone speaking up about that. So okay, so everyone got the sign in link. The word today was refresher. So how about we just kind of go around the room and kind of share some of our experiences so far. Maybe introduce ourselves. Oh, one thing I would like to happen for us is it would last year. Oh, and we just had someone join us. Who joined us? Rebecca. Okay, so Rebecca, if you're just joining us, the here's the link to the sign-in, and the word for today is refresher, and it's just a little Google form to sign in with, and refresher. One thing we kind of did last year that we kind of hit on with the COP is we we kind of put together a spreadsheet with our class schedules for robotics. So and email addresses for anyone that wanted to, like, say maybe meet up like class to class. Um, and I did that a few times with a couple of the teachers, and it was a really fun idea. Like basically, it was kind of like a virtual field trip where we kind of got to see what was going on at other schools and other classes. And so, and it's also kind of, it was really neat for the students, because they kind of saw that they were a part of a larger community, and they could kind of see, um, what it was like at other schools and things like that. And that was especially neat for our school because we're kind of a small rural school, so it was kind of neat to see what other kids were doing. And Kino just shared his email address here. What I'll probably do, is make a. What I'll probably do is I'll make a maybe in the intro to robotics folder, like just in the main folder. I'm just going to make a spreadsheet there. Just a blank Google Sheets, and just share it to everyone here, but with editing access, so everyone can like type in it. So while I'm kind of putting that together real quick, because we want to maximize our time. Let's kind of maybe go around and introduce ourselves so that we can all get to know each other a little better, and kind of maybe talk about some of their experiences with the class, or if you're new and you haven't taught yet, like if you're taking a class right now, maybe some of their worries that they might have about teaching the class next year, and then maybe we could some of our veteran people can maybe address some of those worries. So where should we start off with? Well, I'm just kind of gonna go through what I see one at a time. So it looks like Sandra is the first person up on my screen. So we'll have Sandra introduce herself first. So
my name is Sandra Barber. I teach 7th grade math and child development at Pine High School. I've never taught robotics, totally new. I can work a math problem, but I don't know about, torque and all that. But so it's very interesting. I did have an opportunity though to go to a competition for our sea perch because we just started. We started that last year. That was really cool. I haven't been to one of the other competitions. The only one I went to is the sea perch, but so I'm very excited. But I'm working on it. Kind of nervous about teaching the class, but I do have help from a senior teacher here, so that's going to give me some backup.
okay. And any particular issues you think you might be worried about next year, Sandra?
Maybe the programming a little bit. I mean, it's getting a little better, but yeah, definitely the programming for one.
Okay. Any veteran teacher want to share any tips with her about programming in particular, or because I know several of you, like when you first took a class, also struggled at first. Did you find that it got better after teaching a class, or do you still struggle with it even today?
What I found was block coding, the kids picked it up faster than they did the pseudocode. So what I started doing was I would pull up the block codes and I would have them match the pseudocode with the block code. And that kind of helped it. I spent like 2 days, almost 3 days doing that. And that helped a whole lot. So they could really understand and see the similarities, yet the differences in it. but they were way more confident in doing the block coding. I think it was because in my freshman intro to STEM class, we use block coding when we make the sprites and the scratch animation. So, but that was an issue. But more often than not, really just having them just take their time versus trying to rush through the code. So there were some days where I would put up just some real blanket instructions where they only had to change a couple of lines to get them to see, hey, line number 19, hey, good morning. Line number 20, how those things kind of matched up, like for their final exam. You got to excuse me, we're in the middle of summer school right now, so if you hear some different noises in the background, that's what that is. But we're really getting them to really understand, number one, take your time. Two, there's some basics that you have to understand. So for the final exam, we had to make a maze where it had to travel so many feet, make a 90-degree left-hand turn, pause for so many seconds, go 75 feet, make another turn. And that was without furniture around, where I actually had the floor taped off. And then I came back and put the desk in those areas. So now they can really see it. I showed them a video of how that Roomba robot works. I was traveling through the airport and I saw they had one of those Zamboni floor cleaners that was just like the Roomba. I took a video of it, showed it to the kids. So now, that everything was like, oh, okay, now I get it now. So.
Yep. Yeah, great. And so like you said, so you have them do block code and then translate it into C++, basically. And the the Vex code itself actually will translate from block automatically into Python. Like I think there's just a button you can click to swap between the two. So if this class were set up for Python, that would be kind of great. So it would take a little more work on your part to translate that block over to C++, but they should see it's still the same structure. And I think that is, if they are used to block, yeah, they can definitely kind of plan it out on block first before having to put it in C. Yeah, and I could see how that could be a big help. Yep. So that's a great.
I really like the idea of the matching for like short little bell ringers and things like that, like giving them the pseudocode to match to the actual cloak code. I think that's really cool. So great idea. Thanks.
Yep.
And I wanted to add one more thing to Eric.
Sure, Logan.
Also, like on Vex Code V5 or the app, whatever, there's a library of already pre-made code depending on what you're using. So like it's so easy to drag and drop like what you need. And Vex, at least Vex from what I've seen, especially if you don't know a lot about coding, they've kind of prefabricated several different actions and commands, and they have a good library, and it explains how you use it, what units are used with it, if it's used with time, meters, distance, and it's really simplified having to remember a lot of different actions and codes. And then as you add devices, typically you get more access to different ports of the library. You get access to like a drivetrain, which I think is probably the easiest way to do anything, instead of adding like two motors. A two-motor drivetrain is so much easier.
True.
So,
yeah. And we don't use the drivetrain in the class. It is kind of easy mode but if you're trying to just put together something quick and dirty, then plop that drivetrain in. And of course, in practice, the kids are going to use the drivetrain, like a lot of times, like especially if, for like a competition robot.
It's kind of weird because the drivetrain gives you like, you can use I think exact distance for certain things, whereas like just two motors, you have to use the rotations, or you have to use the percentage or the angles and stuff. So but yeah, my kids when they found drivetrain, it was kind of hard to get them to not use anything else.
Well, that's because drivetrain does all the math for you. So it's doing all this calculations that we're doing manually. So that's like when you set up the drivetrain, unless you give it something like an inertial sensor to work with, you kind of have to say the geometry of the wheelbase and everything like that. And that's what it's actually using to calculate like all the turns and everything for the drivetrain. So it's just that, yeah, drivetrain is just doing all the work for you. But that's true of a lot of things. Like even something like set velocity, there's actually a lot of work that the program's doing behind the scenes to maintain a velocity. And so that's why sometimes it might be better to just use instead of like spinning for like say 50% power, you could actually say spin for like 6 volts or something like that. 'Cause, like if you use the raw voltages, it doesn't actually try to autocorrect to maintain that. Sometimes yeah, raw voltages work better.
That's cool.
If you're yep. But yeah, that's a good point, Logan. Well, hey Logan, since you're on, do you want to go ahead and introduce yourself and tell us a little about you?
Yeah, sure thing. I'm Logan Blanchard. I teach at Iowa High School in Cowichan Parish. This is going to be my third year teaching robotics. I also teach engineering design development and intro to engineering as well.
And you're the lead teacher for that over the summer, right?
Yes, I am. Hold on one second. My dogs decide they're going to fight in the living room. Sorry, I have a newish puppy, so he's kind of rowdy. Let's see. I am the STEM coach for my high school as well. And traditionally we've done VEX in the past. We have attempted C-Perch, but have never fully actually competed in a competition. That is something we plan on doing next year. We're going to kind of prioritize more of those styles of robotics because we like Vex a lot. The kids, it's real plug and play. It's real simple for the most part. I mean, it can get complicated. Don't get me wrong. But like C-Perch is like they're actually soldering like pieces together, which is not something that you see in Vex. Vex has all the components put together where you just plug in wires, but nuts and bolts is a real awesome complex and cutting metal and kind of adjusting that. But we have a pretty strong STEM like region down here. And regional it's the Region 5 STEM Center, which we do like they do cover more than just Cowichan Parish. But we have a lot of competitions locally that we're going to be doing as well.
Yeah, you guys do leagues, for instance.
What's
Right?
that?
For instance, you guys do leagues there, right? Like
Yes,
a Vex.
yeah. So they do a league. It's like Thursday night league and stuff, and then at the end of it's like it's basically one robotics tournament broken up into like maybe what a month or two. So it's pretty, it's a lot less I guess exhausting than a traditional Saturday morning, going till like 5 to maybe even 10 o'clock at night, depending on how intense they are. But uh yeah, so that's it for us. So we're pretty excited for next year. We're gonna do a lot more local. Like we have like a catapult competition that we're gonna be trying next year and stuff like that. So we're kind of branching out a little bit. So
That's great. And do you have any advice you want to share to new teachers?
advice in so I guess I taught freshmen this class. That's all I've taught. I mean, maybe like one junior. So that's with them not really having a strong math background. And this is like there's a lot of physics in this. Like, it's like lower level physics stuff, but what I've had to kind of like really do is kind of give the kids some grace and give them some time and really dig deep on the math portions, and kind of like sometimes I had to kind of teach some algebra principles or some principles before that because they were freshmen, they didn't have that strong background. And I had some kids who were in kind of we call it math essentials, which is like a pre-algebra and that one. So they weren't the strongest, but they were really interested in robotics. So it's kind of like it's really focusing on that interest in the actual like portion to kind of help them motivate the lack of the math portion. And there's not a whole lot, like it's not like a ton of I guess math. There's a good little bit of it, which I enjoyed it a lot. The kids don't, but and bringing making sure they physically touch the gears or they see the different changes and stuff like that is a big deal. And the program does a really good job of like guiding you through it, stuff like that. So just kind of leaning in on them and Eric, and they have the support like every month or every 3 months, there's a little meeting where you get together, you talk about what you're going through. You cannot miss that if you're having trouble. So definitely lean on your support groups for sure. Because I do the engineering design development one, and we don't really have like a whole lot. I think it was me and Chris. Like, Chris Lang's awesome too. If you need any help, he's definitely there for you. But he's like the only. It'll just be me and him most of the time. But you know, he really needed help. He got it. So everybody's willing to help you. All the support's willing to help you. Anybody will really lean in and give you a lot of assistance. So don't be afraid to do that at all.
Yeah, you'll definitely be seeing me in the EDD COPs this year because we didn't actually end up teaching a class last year, but we're teaching
Okay,
it this year. So
gotcha. Okay, yeah, man, more than welcome. So
yeah, and all of you, I recommend you come to the COPs at least so I won't be lonely sitting there that afternoon.
yeah, it can get quite boring if like nobody shows up. I had like a couple times where people didn't show up, but sometimes the reminders don't pop up for the
Yeah,
class people forgot to go.
that's true too. Um, okay, well, but thank you for sharing with us, Logan. And how about Miranda? Miranda, you're new to the class. I mean, so this is your first year, but how are things going with you?
I'm Miranda Moore. I'm going to be teaching robotics and introduction to engineering at the Denham Springs High School STEM and Robotics Center. So even though this is going to be my first year teaching robotics as a class, I'm also a mentor for our FRC team, Denham Venom. So I've been a mentor for them for like 3 or 4 years. So my husband's the head coach, and he's previously taught the class, and so I'm just kind of basically joining him at the STEM Center and teaching those classes for that. Um, yeah, I don't really have too many concerns about the teaching of the class. I think my biggest concern is I've previously taught AP Environmental Science for the past 6 years, and that's mainly a senior level class. And I'm very used to grading very rigidly and very harsh because of that. And so I'm worried I'm going to be too hard on the kids, especially when it comes to, the engineering notebooks and those kind of things and the math and those kind of things. Yeah, that's my biggest concern is the switch from seniors to freshmen.
Okay. Anyone want to share any of their grading strategies, like the veteran teachers? That would probably be interesting because we probably haven't talked about that a whole lot in the training class yet. So, um, anything you guys do with grading?
I try to make sure that I always give a rubric um, for as many assignments as I can, uh, so that the students know exactly what I'm going to be looking for on the assignment. It keeps me fair as well, just like, especially if I have somebody that turns something in late and I can't, if I don't have a rubric, I don't remember how I graded it. So that way too, the students feel like whenever I'm grading, it's not my opinion. It's like you did not do this thing that I asked you to do. And so uh, that's a big one for me, is just trying to make sure that they have a rubric for every assignment that's going to go into the grade book.
Mm-hmm. And I know LSU provides rubrics for most of the projects, probably not everything. Are there any custom kind of rubrics that you kind of do? Like, do you do a lot of modifications to those standard rubrics, or?
I tend to, yeah. I'll either add more detail, or if I feel like, okay, we didn't really press on this particular thing in class as much, maybe I'll adjust the weighting of a particular part of the rubric. Say, okay, this is really the priority for me right now, so I want their while loop should be the highest priority, making sure that they get the syntax correct on it, as opposed to, whatever else we may be working on. Or whatever else may be required for the assignment to be done. So I'll adjust them as I see fit during the class, just based on how my instruction went.
Okay. And thanks, David. And actually, David, do you want to go ahead and introduce yourself and the school you're from and all that, since you're, or did you? I don't think you've gone that far with it. I mean, you shared a lot with us so far, but
No, I haven't said who I am. So I'm David Bennett. I work at Central High School. That's physically in the East Baton Rouge Parish, but it's part of its own school system. So Central High School is its own thing. And this is my second year teaching robotics. My first year, I was, before I started working with robotics and the engineering pathway classes, I was teaching chemistry and physics. But we had a teacher that they left like the second week of school. And so we had a bunch of kids in these engineering classes for the first semester, just kind of waiting for a teacher. So they asked me to come and take over those classes 2 years ago. And so that's how I started. I kind of started halfway through the year. And the reason they picked me is because I've only been teaching for 4 years. Before that, I was a control systems engineer. So I have engineering background. So that's why they wanted me to be the engineering teacher. And it's been great. It's a lot of fun. The hands-on nature of the classes are they can be exhausting, especially if you're teaching, say, like intro to engineering and robotics in the same classroom, because you have to make sure that all of the intro to engineering stuff, whatever they're building, gets put up, and all the robotic stuff is available for your robotic students. So there's a lot of running around and making sure that you have all of your equipment. And if you have more than 2 preps, just making sure that you can get all of your equipment put together or in the right place. That's the exhausting part of being an engineering teacher, in my opinion. The fun part, though, is that there are days where you're just like, all right, guys, build. And, they come in and you just float around and make sure that they're doing what they're supposed to be doing and not, stabbing the tables with a screwdriver or whatever. But
yeah, I have a mystery
I
hole in one of my tables.
what's that?
I have a mystery hole in one of my tables that I think over the course of the year, a student started whittling a hole.
Yeah. So in my intro to engineering class, whenever we were building some bridges, or no, it was the catapults, I brought in some drill bits that would fit into a hand screwdriver, so that they could drill holes in the little pieces of the little wood popsicle sticks and stuff like that. And yeah, so now I have a lot of small holes in my tables and chairs. So it's like, okay, lesson learned there. But yeah, so it can be exhausting, but it's a lot of fun, and it's really rewarding to see kids get excited whenever their project functions properly, and they get to be more creative. So that's the upside of being an engineering teacher. I don't know what else to say. That'll work.
Yeah. Um, thanks. And you've already shared a lot with us already. Is there any like if you were to give just one piece of advice to the newer teachers, um, what would you say?
It's a tough one.
Or is that
Let me
putting you
think.
on the spot?
I would say, um, it's probably just don't be afraid of chaos in the classroom if it's productive chaos. So like a lot of teachers are used to, if you're like a math teacher or whatever, you're used to a quiet classroom with, all of the kids working on a particular single item. And the shift that I had to make was to a point where it's like nobody's doing the same thing in the room. And everybody's working on something, but everyone's being productive. So that chaos and that noise are something that you kind of have to learn to embrace. And you just walk around and make sure that there's nobody doing something that they're, drilling holes in chairs. But most of the kids want to build a robot. It's cool. It's fun. So if you give them the directive to do something and it feels like a challenge, then they're gonna try. And you give them at the beginning of class a little bit of formal instruction time where it feels like a classroom. And then the second half or second 2/3 of the class should be chaotic. It should be noisy, and kids are going to argue, and because we have to put them in teams because it's just too expensive and there's not enough room for everyone to build their own robot, unless you have a really fortunate setup. And so they're going to argue, they're going to fuss, and that's part of the class too. They're learning to work in a team because speaking from my personal experience as an engineer, you have to work with people every day and deal with irritating personalities. And so that is a skill that we're trying to build in this class. It's embedded in it just by the fact that they have to work in teams for every project.
I have a question. So David, how do you so I know for me, coming from like a science background, I have a really, or my students sometimes have a really hard time of like fear of failure. And with engineering and robotics, like failure is part of the learning process and it shouldn't be scary in this context, but they're coming from that academic side of things a lot of times. And this is their first experience with the idea that like it's okay to fail. So how do you kind of walk them through and motivate them through that hard learning process of it's okay if it doesn't work the first time?
You have to talk about it a lot. And one of the first things I do whenever I get a new group of kids. So last year I did it in my computational thinking class, and then in my 2 years ago I did it in computational thinking. Last year I did an intro to engineering. So whatever time you get them at their youngest point, I have story time one day early in the year, like the first week, and I pull out this book that I read to my daughters. It's called
Great engineer.
Yeah, Rosie Revere Engineer. My daughter filled in the blank for me here. It's this. I mean, it's a child's book, but it's about the growth mindset. So it's a little girl, and she tries to build a helicopter for her aunt out of junk. And the first time that she builds it, it kind of comes up off the ground and then it falls down. And she has this fear of failure and she's just devastated. And then the aunt hugs her and says, "This was great. Let's do it again." And it reframes it for her and teaches her the growth mindset. So that's, I make a big deal out of it. I'm like, "All right, guys, we have a really important thing to do, and it's story time." And then like I read them this child's book, and I try to reinforce, that this is part of it. I tell them every student in my class deserves to fail. That's a phrase that I'll try to say at least a few times near the beginning of the year. And what I mean, and I'll explain what I mean by that is you deserve the opportunity to fail at something or for something to not work out, and then you learn from it. And then there's also, I'll show videos whenever I'm talking about the engineering design process. There's this YouTube channel, and I'm sure you could find a million like it, but there's this YouTube channel. There was a video that went viral, I guess like 10 years ago, of this guy, and he built this machine out of plywood that he's cranking with his hand, and it's dropping these steel ball bearing like marbles onto like a xylophone and a bass guitar, and it plays music. The name
Winter
of the
Garden.
Winter Garden, one of my, and he's continued since then for the past 10 years to try to build a better version of the machine that he could go on a world tour with. And he's still working on it. And he's got a lot of great videos about him going through the engineering design process, because he builds something and it looks like it works, and then he starts testing it more and it fails, or it drops marbles all over his floor or whatever. But every version that he makes is a little bit better. And so some of those videos that I've found are really, really good examples of the engineering design process. There's one in particular that he made recently about a marble divider, and he goes through like 12 iterations of the engineering design process, trying to figure out what's the best way to divide marbles from one line into four. And so just doing little things like that on a regular basis, I feel like helps the students kind of change their mindset, at least in your class. You have to be intentional about it, though. If you just tell the guys or tell the kids when they mess up, "Oh, you gotta have a growth mindset," and that's it, it's not going to work. So they'll feel like they've failed, and in a negative way. So be intentional about it. Put it in your lesson plans. That today we're going to talk about growth mindset. And I can try to find some of those videos that I was talking about with the marble machine guy, and post them somewhere so that y'all can have access to them.
Thank you.
Thanks, David. Okay, so let's hear from some other people. So we got a couple of Chris's with us today, but so let's hear from Chris DeJater. Did I get the last name right?
Facilitator.
Okay, so not even.
All good. I don't know what to say though. I'm Chris Degater. I teach at St. Martinville Senior High, in St. Martinville, down 20 minutes out of Lafayette.
How many years?
Yeah, I taught robotics for the first time last year. So this will be my second year coming up. I don't know. I have a lot of fun with it. I had some students that had a lot of fun with it. My biggest trouble was getting to the other students that didn't have a lot of fun with it, which was unfortunate. But it is what it is. And I mean, eventually they figured out that even if they didn't want to do it, they had to do it. So, but most of the class had a lot of fun.
Yeah, that's good. So yeah, so one challenge, I guess, is to keep the kids interested, right? The kids that were just kind of thrown in the class and didn't want to be there. Um, so did you find any solutions to that through the year, or
Um,
not yet?
I don't know about keeping them interested. Things like the notebook and keeping things due, like by the back half of the year for every single project, I had them turn in a rough draft halfway through just to show where they were at. Um, because what those two kids that didn't want to do anything were doing was putting everything off to the last day and doing the bare minimum in the notebook every day and making it look like they were doing work like when I would come around. And then as soon as I would turn my back, they would think I wouldn't notice that they were immediately not doing work again. Um, so putting in like those checkpoints basically at least ensured that they engaged with it every day. So even if they weren't interested, they were still picking it up and still learning. Um, and I pretty much kept it at that because it was 2 out of a class of 11. So I'd rather focus on the 9 that were getting a lot out of it and make sure that those 2 were at least learning, than focus on those 2 at the expense of the other 9.
Okay. Yeah. Well, thanks for sharing with us, Chris. And did you find that the summer training helped you a lot
Yeah,
prepare for you?
absolutely. Oh yeah,
Okay.
for sure. Um, the whole time I was teaching the class, my brain kept going, I remember this, I remember this. Yeah,
Okay.
a ton.
That's great. Okay. Yep. So hopefully that will reassure some of our uh, newer people.
Yeah.
But
And
okay, thanks a lot. Yeah, go ahead.
I'll put my email in that spreadsheet and everything. And if anybody has any questions, like feel free to email me or whatever. I don't know, I'm not good on the spot.
Um, so also I did put that spreadsheet in the just the main intro folder, and I went through and gave everyone editor access to it, and it basically if you just want to share like your name, the name of the school, um, and then also your class schedule and your email address and your class schedule, and that way like you can look on like once you get your class schedule, you can kind of put in your times, and then you can look at other people's times and say, oh well, we have classes that match up at this time, so maybe we could do a Zoom call between classes and maybe like coordinate like maybe when they're doing the poster presentations, you could have them share with a whole other school, or maybe at the end of a project, you can have the kids kind of show off what they built to other classes, and it really does improve the motivation of the kids when they're actually showing off to a whole different group of people that they normally don't see. So yeah, so I would recommend it, and it also kind of promotes that kind of community there too. So how about we hear from our other Chris, Chris Lang? Would you like to share a bit with us, Chris?
Yeah. Hello, my name is Chris Lang. I'm at Barb High School in Calcasieu Parish, right down the street from Logan. I've been teaching in the Pathways program. This is going to be my 6th year, my 5th year teaching robotics. I teach intro to engineering, intro to robotics, EDD, and POE. And I've had a good time. I've learned a lot. I would say it sounds weird saying it, but as like a seasoned quote unquote teacher, I would say the biggest thing is to get out of your own way. I think like Miss Miranda was saying, a lot of teachers, if this is your first time teaching, this class, you have like a very structured way about doing things. They walk in, they do the bell ringer, then you have this next and this next, like you have it down to the minute. And the best thing that I've learned in my 5 years teaching this class is to allow the kids to kind of go the way they're going to go. Don't let yourself correct them and stop them from making mistakes. Even if you see that it's going to go completely wrong, that the robot is not going to do what it's supposed to do, you allow that to happen so that when it doesn't work, now they're going to come to you for, hey, well, this happened and why didn't my robot do this? And then you can kind of lead them to figuring out their own answer. Like, hey, well, what did you want the robot to do? What did you code the robot to do? That type of thing, and let them get back to where it is. And earlier somebody said they were concerned about the coding part. I think the biggest thing for the programming or coding, especially early on, is it doesn't have to be cute. It has to work. So as basic as possible. So even if it takes you 200 lines to do something simple, you let them take those 200 lines to do something simple. And so like before, I also taught the computational thinking, and the whole purpose of the computational thinking class is to get people to break down bigger problems into smaller problems, and you start off at the lowest point. I've learned that as they get better coding, they'll realize how they can make the coding more efficient. But in the beginning, their coding isn't going to be efficient. So don't put a lot of pressure on yourself, especially in intro to robotics. Don't put a lot of pressure on yourself. This is their first time learning how to build robots. And they'll get excited on your first robot. Like the first robot is so basic, you just use the control and they just put wheels on they make a frame, they put wheels on it and they roll it around to play like a little, almost like a soccer game. And at the beginning of the year, my kids are trying to film it to show their parents. Like they want their mom to see that they built a robot that can play soccer. So that's the part that catches the kids when they actually build a robot that does something. The first time they put the arm on and the arm can grab a bottle of water, they want to film it and send it home to their parents because even their parents don't believe that they could build a robot. So I would say get out of your own way. Don't try to be too rigid. Allow the class to be more of like an exploratory thing. I wouldn't expect them to become experts at the end of this class. So let this class be more of an exploratory, interest piquing. They're going to learn, but also give them the space to just like enjoy, to fail, to fix it, because the best moments they're going to have is when their group couldn't do something and they figured it out. And they come up and they're going to come up with stuff that you didn't think would work. And it looks terrible, but it's going to work. I think last year I had a kid, they didn't do the arm. They did a vertical lift. They used the sprockets and stuff to do a vertical lift. And I thought that thing was going to fall apart, and it was moving left and right while they were trying to lift up the little ball, but they got it to work and they were so excited. So, yeah, my advice in all of these, if you teach more than one class in this program, my advice as a person who teaches 4 is to kind of teach yourself, because I also teach chemistry. So I understand the whole like rigidity of classrooms, but in the engineering pathway, I think the best thing to do is learn how to kind of get out of your way and let the class kind of be a failure to learn class rather than you just giving all the information and trying to always keep them right. Let them make mistakes and let them fix them.
Yeah, that's some great advice. Yeah, thanks for sharing, Chris. So how about we hear from let's hear from Ashley. We'll hear from one of our newer teachers. How are things going so far?
I'm Ashley Fontenot. I just recently got a job at Haynes Academy in Jefferson Parish. I am kind of coming into this like brand new. I'm a history teacher, so I've never taught anything math, or I taught science during COVID, but it was like a virtual online learning class. So I have absolutely no content knowledge like of any of this. None of the math. And so I really am doing a lot. Like last night I did the unit 1 through 4 homework, and I made myself a Quizlet, and I'm trying to be as prepared as possible because I like to be the person who has all the answers, and that I know that's not going to be possible this year.
Okay. And so so you still have some anxiety as far as like the content goes a bit?
Yeah, I do. I guess I kind of feel like everybody else is coming from at least a math or a science background, and like I don't know almost any of this. So this is all brand new to me.
Can Are there any veteran teachers on here that came from a like a humanities background that want to share their experience like transitioning? Or are we all just science people?
Well, I'm not
Yes.
a veteran teacher for robotics, but I have been doing all this stuff for a while. I actually had a major in history, minor in poli sci, with a master's in secondary social studies. And then whenever I interviewed for my first job, they said, "Can you teach a lower level math?" And I said yes. And so um, I had a full year of student teaching, one at LSU, uh, the lab school, and one at Central Baton Rouge. Um, did all that to never teach anything in the humanities in my entire career. And I'm just finished my 19th year. So I've taught basically every math all the way up to, I haven't taught advanced math or calculus, but I've taught several dual enrollment maths. Taught AP physics. We do the PLTW curriculums for our introduction to engineering design and our principles of engineering and our engineering design and development. So I've taught 2 of those. We haven't had a kid yet who qualified to take the EDD class. But say all that to say this: it's very doable as long as you're willing to learn it. Because I had to teach myself physics. I had never taken a physics course in my entire life, and had to teach myself physics. It was hard, but it was worth it because I got to learn it as the kids were learning it. Um, And like I told my first year kids, I was like, look, I've never done this. And we're going to learn together. We're going to go through, we're going to do all the experiments together. We're going to figure this all out. Had a really good year. Had a couple kids pass the AP exam. That was fun for me. A couple years later, had the school's first ever 5 in general. I don't even think it was just in physics, but in general on the AP exam. Had some success, uh, and you can too. I mean, it's just how much are you willing to put into it. You like to be the person who knows everything. You're going to have to put in the work to learn everything, and so that's kind of the catch to it. But you'll get into it. Like that. That's what I've noticed about everything that I've done is that I get into it myself, and so I want to learn how to be a better coder. I want to learn how to be a better engineer. I want to learn how to do all these different things, and so you go through and you figure it out, and then whenever you figure it out, you're better prepared to tell the kids. I'm a much better teacher now than I was whenever I started physics and engineering, and I'm still not good enough in my opinion. So um, that's me personally, but you'll be fine. It's doable. You'll be fine. There's a lot more information available and easier access to get it now than there was 19 years ago. Um, YouTube was just starting then, so it wasn't really a thing. Now there wasn't any. You didn't have to worry about ads back then, but like it was still barely a thing. And now you have access to pretty much whatever you want. So I mean, there's a lot of help, and this is a good community. It looks like. So I would definitely say lean on them as much as possible.
Yeah, definitely
Hey,
show up
I
to the
would
see
I would jump in real quick.
Sure.
Miss Ashley, I would actually say that you're probably at an advantage because the thing about math and science teachers is like even like Miss Miranda was saying, we're very like rigid. There's only one answer. Like when you do a math problem, there's only one answer that can be turned in. When I'm doing a chemistry problem, if I want the formula for sodium chloride, there's only one way to give me sodium chloride. So it's kind of like an unlearning of that you have to do to be an engineering teacher, of that rigid, there's only one way to do things, that math and science teachers have, and you don't have that. And so I think you're at an advantage because although you are the person who wants to know everything and be that content expert, the one thing about robotics and engineering in general is that there is no one way. There are so many different ways. Like Eric's been teaching this for a long time, and him and I are going to look at a code and see it in two different ways. And he's going to code something one way, and I'm going to code something one way, and they might both reach the same goal, but we're going to go at it so many different angles. So you're not going to be a quote unquote content expert on this because there's so many different ways to do this. So you're at an advantage in a way because you can be honest with the kids, and that's one of the best things to do in this engineering thing is let them know, hey, look, I don't know every single way. You're going to come up with some ways that I never thought about because it's all about how your brain processes information. And we're going to learn from each other right now. So, like, I wouldn't look at it as, I know it's kind of nerve wracking, but honestly, you're in a better position than some of us were starting out because as a humanities person, you're already kind of geared of multiple avenues and how things can be seen in different ways and all that way. And that's important for this class because they have to know that there's more than one way to do this. So like if Johnny coded it this way, every kid in the class doesn't have to code it that way. As long as the robot does what it's supposed to do, then you've coded it correctly. Sure, your code could be more efficient, but if you got that robot to do what you needed it to do, you've done what you were supposed to do. And so not having all the answers is sometimes a good thing because we want to just tell everybody what to do when they come. Well, you need to do it this way. No, there's so many different ways, so many different avenues the brain goes, and so many different ways it can be seen that you're like a fresh canvas and you're going to see all these different ways kids are looking at it and it's going to help you understand it in more ways than one. So I wouldn't look at it as a you're starting off as a disadvantage. Yeah, you're going to have to learn with the kids, but that's also a great thing. So you're in a good position. I wouldn't worry about it.
I'd also like to tack on one thing if I can.
Sure, Rebecca.
Um, I would just say you have to lean on the fact that you really don't have to be the expert. I have kids who came into my classroom last year who had, honestly, they were better coders than me. And just because they've grown up doing more of it. And sometimes I let them be the expert in the room and not just that, sometimes you're like, you can only, sometimes help one group at a time debug their code, but you have kids in the room who have more experience or have good experience doing it. And I'm like, okay, you've got yours working. Can you please help, this group next to you? So lean on their expertise as well. That would be a piece of advice that I would give.
Yeah, and that's excellent advice, Rebecca. Thanks for sharing that. Yeah. So let's see, who have we not heard from yet? Let's go back to Josh because Josh was just talking, but I don't think he actually introduced like where you're from or well, we got a good history from you, but just not what school you're at. I don't think or any of that.
Yeah, I'm Josh Beard, Drader High School. This is going to be my first year with Intro to Robotics. I've been the robotics coach and aerial drones coach since COVID. I got a text from my principal during whenever the Hurricane Laura occurred, asking if volunteering me to become or to write grants to create to create a robotics team. So we started a robotics team that year. Had minor success. I had no clue what I was doing. Following year had a little more success as far as our robots were better, but we still weren't as good as some of the other teams. And then we got into aerial drones. Uh, we've been much more efficient and more. We've been kind of lucky, I guess, with the drones. We've made nationals 3 straight years. We didn't get to go this year because it was too expensive. But we went the other 2 years. One year we sent two teams, so that was pretty cool. Um, as far as the course itself, this is my first experience with an LSU class. Everything else has been PLTW. They are similar but different. I'm curious whenever they come up with the new model for next year, how close they're going to be then as far as how they align, and then if there's an end of course exam, what that's going to look like. I know now we have a final, but maybe there's going to be somewhere down the line an opportunity for that to be college credit worthy. That would be really cool if they could ever make that happen. Make the class a whole lot more um, accessible for some kids who see it as just an elective that doesn't really get them anything. I would like for them to have an opportunity to take advantage of it and get some kind of credit for it for their future as well. As far as things that I'm really concerned about, my biggest concern right now is with the PLTW curriculum. I don't know about the LSU curriculum, but POE uses a lot of the same parts and brains and stuff like that that Intro to Robotics is going to be using. So I know David mentioned earlier that you need to keep everything separate, but for me, they're going to be basically back-to-back courses, and it's like, okay, and I know that Eric has mentioned that we're going to have to assign everybody their own port for whenever they're downloading their code, but I'm more interested in how are we going to do the frameworks and everything for the various things that they're going to have to build, and then they're going to have to be smart enough to attach a brain site. That way, everything can be easily taken off and put back on in a different spot for other people. So that's something I'm a little concerned and curious about at the moment. I don't know how big my courses are going to be yet. I know that I've heard several kids are signing up, but they said the intro class, and I don't know if they meant intro to robotics or intro to engineering design. So I know that something's going to be popular. I just don't know which one it's going to be yet.
Yep. Yeah, like last year that we had a second section of robotics, and I was able to convince my school to order a few extra kits to make sure so because yeah, it would be really hard to share kits between classes, especially since they're building their own robots, right? And that's like multiple day projects, and you don't want them, and the kids don't want other kids messing with their stuff. So um, so yeah, I would be kind of curious how you'll work out sharing between classes. Maybe it'll work out that you have enough parts available. And hopefully that won't be the case.
If you haven't already started working on your QSM grant, I would strongly recommend write yourself a QSM grant. They tend to
That's
get easily
$2,000, right?
approved. Yeah, easily approved. I've gotten it twice in my 4 years of teaching, and both of those were the times that I wrote one. I've never been turned down. So QSM grant's a great way to get a couple of robots, or if you want to just get a bunch of brains or something, might be a good way to do it.
I got my pneumatics kit through the QSM grant. Like kind of wrote up a unit on doing pneumatics and used that for the QSM grant. So yeah, that QSM grant, they Vanessa talks about it a lot, and she typically says that there's a lot of years where they just don't give out all the grants because they don't have enough people applying for it. So
hey Eric, this is Daniel over with Miranda. So
hi.
Yep, I know I'm not going to be teaching intro to robotics anymore because I'm passing on a torch, but I've been doing it since 2018, 17, whatever that is. At the STEM Center, we're kind of unique because I teach five classes of intro to robotics with 20 kids per class. So we had a lot of kits, but the issue is always the brains and always the batteries and always the controllers. And so we ended up having to, for a while, we separated the kits out into multiple components. And so we got the V5 full kits, the big giant ones when they first opened up. And so we were able to separate the metal and a lot of the stuff like that of the kits so that each individual team would have their own. And then the batteries and the brains, they would remove from their kit at the end of the class, and they would put them in a different location. And then the next class would come and get those batteries and those brains. It's worked different ways. One way we tried one year where they each had their own, slot within the brain itself. In the end, it ended up being easier for them to have their code saved, and they would just upload the code again as it came across, and it tended to work pretty easily. My advanced robotics class, which is not the one connected to LSU right now, they would get their own full kit because, of course, they're trying to do a lot more different innovation type things. But it didn't actually present too much of a problem as we would switch back and forth.
Okay, so did you physically move like the brain from like one metal frame to another, that
Yes.
kind of thing?
Yeah, and so what we would do is we made sure we had enough brain clips, the little attachment clips, because those are really easy to take on and take off from the brain. And so it would become part of our classroom procedure. At the end of the day, before they left for the class, they would have to take the brain off and they would put it in a location. And what I would do is I would assign the same brain to the same groups each class. So the way I separated my classes out, each table had their bin, right? And then I had the same thing for every one of the classes. So say, for example, table 1A, so first hour A table group, they would be exchanging their brain with 2A. And so that way, if for some reason I went to 1A's group, like a 2A couldn't find their brain, instead of them going and taking it off of the other group's robot, because I didn't like that, I would do so, but I would dock 1A's participation grade because they didn't finish.
Because they didn't set up or put up like they should have.
Exactly. And it would sometimes be issuey. Sometimes they'd forget to do it, especially as we got along in programming and things were getting rushed and they were trying to get everything done and they'd put it up and and so you have grace in those instances, but that seemed to work out really well. And so I had a huge, basically shelf where I had individual plastic bins, and those bins, 1A, 1B, all those through the tables. And it made it really easy too to change groups, because basically when I would shift one group to a different table, they would shift what kit they were using. And which would help in that regard is because every group wanted to make sure they were going to have a good kit going through. So if they disassembled a robot, for example, after the first unit, they wanted to make sure they were going to get a good kit when it came back that was actually taken apart properly. And so they did the same thing in theirs for the next group that would have theirs. And it just made sure the organization stayed pretty well done at the actual little bins they were using.
Yeah, that's some great advice. Thanks for sharing that. Yeah.
Hey, Eric.
Yes.
I was also going to tell Josh, I know y'all are using Project Lead the Way in Dorita, you said, but I know Project Lead the Way is under like a contract for so many years, and then you have to renew it, and there's like some costs involved. And you were talking about your kids having stuff that they can use in the like a reason to take the class, I guess. And that's one thing LSU has done well. Their intro to engineering can be a dual enrollment, so they can get college credit for it. The engineering design and development is an arts credit so you don't have to take a art class other than that one. And then the POE, the principles of engineering, is a physical science credit. So like if you have the right kid, they can take their POE as their physical science. So they can go straight into chemistry and physics and biology, and they don't have to take physical science because the POE counts as a physical science credit for Louisiana. So like LSU has built in some things that makes it worth their while to take the classes. So like if you were looking into that for the future, that might be a good, when it's time to renew the contract for Project Lead the Way, it might be easier for you guys to switch over to LSU stuff because it doesn't cost up front, and it has credits for them for their schooling that they don't have. They can lose certain classes to be able to take the engineering classes.
Mm-hmm.
Okay. Yeah, right now for EDD's the same. POE, they actually offer it's a science credit, but they also offer an opportunity for college credit if you score. It's like AP basically in that aspect, where if you score high enough on the exam, you potentially can get college credit. The problem is IED for right now through PLTW, and I've been working with one of the ladies who's in charge, I guess, of my area, trying to get it to be an art credit as well, because I mean, there's a whole lot in engineering design, at least on the PLTW side. I'm assuming LSU is going to be really similar, but there's a whole lot of art content in there that if they would just reflect it in the way that it's coded, that could potentially allow us to have that as an art credit as well. But definitely in the future, LSU might be something, a better option maybe moving forward.
because principles of engineering can be a dual enrollment class, the LSU one. And as far as like things like energy-based standards, I asked Vanessa about that. There is an industry test, like the RSE Foundation has an industry-based standard. I think they worked with Lockheed Martin to develop it. So there is an industry exam out there. But it's a pretty difficult test. Like there's a lot of engineering on it as well as and so if the robotics class were ever to adopt that test, it would the class would need to be heavily restructured and revamped to make sure that all the skills are covered. And Vanessa kind of said like the original spirit of this class was to get kids interested in engineering and interested in programming in a way of and if the class is more like focused towards that industry based test, it might kind of destroy some of that because you would be so focused on making sure that content that the kids understand it, that you wouldn't have as much of the exploration with the projects that you would probably want. So
do you know if so right now most of our engineering stuff, our pre-engineering credentialing stuff is through PLTW. LSU has their own pre-engineering credentialing, but most of it is similar. On the PLTW side, they have to have computer science. On LSU, they can have multiple things, including robotics. Can you crossover? So could I have kids take 3 PLTW courses and 1 intro to robotics, and that count as their 4th class towards their credential, their pre-engineering credential?
like as far as like for the endorsement, like the
Right.
STEM
Yeah. So like
endorsement.
right now they can take IED, POE, and EDD, and then on the LSU side they could take those exact same 3 courses as far as the course codes are concerned, and then robotics, and boom, they have their credential. Whereas on the one that I'm looking at, they have to take some other course, whether it be computer science or something else like that. Would that be doable, or
Well, I'm not like a Kane Center person, so so that would probably be more of a question for Vanessa. My guess is going to be the answer would probably be no, is because I think LSU wants to make sure they maintain some oversight over the curriculum, and that's kind of like why we have like this intensive 2.5-week training for every teacher that's doing these classes, and also like why we have these yearly refreshers and the COPs, because I think they want to maintain some standard of quality, and if they're like pulling into Project Lead the way that they don't have any control over that, and so I'm pretty sure they'll probably tell you no, you can't mix and match.
I would say
That's
look
my
on Louisiana Believes. So
yeah.
the old,
But I mean,
the old way it was set up. Go ahead.
Oh, I'm sorry. Go ahead, Mike. Chris. Sorry.
The old way it was set up, you could get the state credential by mixing and matching. You could, because the state only required you take certain classes, and both Project Lead the Way and LSU classes were recognized. So like you couldn't use the same, but like each class had a level. So you could have taken the Intro to Engineering from LSU or Project Lead the Way, and so on and so forth for the different classes. So you could mix and match. But as of like last year, they adopted a new standard for the credential. And so like it is almost impossible to get a gold seal credential on your high school diploma because of all the computer sciences and all this stuff. There's only like 2 schools in the whole Louisiana that will offer enough courses for them to get a gold seal. So the credentialing you're talking about, it used to be possible under the old way, but they changed what they're requiring for the credential. So I would go back on Louisiana Believes and look up the endorsement seal, what they require, and see, because that will tell you if you can have which classes you could have and how it works out. But the old way, you could have like, let's say you went to one school and you took Project Lead the Way for intro and POE. If you were go to a different school and they had LSU, you take the 2 other courses through LSU, and it would still count as your seal for your credentialing for your diploma. But they changed it as of last year, and it got a lot more difficult to get the credentials. So I would go look on Louisiana Believes at the pre-engineering pathway, and you should see what classes correspond to which thing.
Yeah.
Can I go back
thank
to something that we were talking about earlier when it came to the VEX clawbots? Again, because my school goes by semesters, what I did was when we changed semesters in January, I had my new class, they came in and they took apart the previous VEX robots. So I had them take a picture of it, download it to the Chromebook, take everything apart from the screws, lay out all the pieces and start all over again. I found that worked a whole lot better versus trying to keep ordering, because I have an influx of all these extra pieces and parts, versus just recycling, right? Then once they recycle and they put it back together, those students who really get that grasp, those are the ones that I start kind of pushing more towards the competition side of it versus is really understanding how the robotics works, how the sensors work, so on and so forth. The main issue is when it goes back to that coding is we can do all different type of conversions where we convert from feet to inches, so on and so forth. There wasn't 2 robots that when we put in the velocity, all took off and moved at the same speed at the same time. It didn't matter how we went back into the drive chain and changed it. We did a bunch of debugging, but for some reason, I can say set the velocity at 65%. One would be going like 75%, one would be going 50%. So, but again, that was the whole part of that journey. In regards to the C-Perch, the students really like the C-Perch more than the VEX, just because with the C-Perch, they had to solder all of the fuses, we had to cut all the pieces, but I like the VEX better than the C-Perch. So what we came up with was, how can we put the 2 together, right? How can we use the C-Perch and use that arm from the VEX in regards to the C-Perch, and it worked out pretty well. So for any of you new teachers, do not be afraid to fail. Do not be afraid to fail. Do not be afraid to ask questions. Do not be afraid to send out an email or to simply say, I don't know. However, I have some people who can come in and reach out, because what I did was I reached out to the Center for Robotic Surgery. I had them come over once a week for about 3 weeks, just so they can see how that arm on that VEX robots compared to how they use certain robotics when it comes to doing surgery, how it all tied in. And it was those little things like that that helped out a lot. I had someone come in from NASA for a couple weeks, just talk about just basic programming, so on and so forth. So that allowed me to take a step back, for me to also learn, for me to look and, and kind of be able to facilitate throughout the room. So don't be afraid to reach out to those people who are experts, to have them come in, because some companies, they have those tax write-offs, so to speak, where they want to partner with a school, they want to come out and help. So use that as often and as best as you can.
Yep. So some more great advice there. Yeah, and pulling out outside experts is a really neat way to keep the kids engaged, for sure. So there's always kind of a meme with the kids in the VEX community. Always a water game is what they want. So I guess you're actually doing a water game, mounting VEX parts to a C-Perch robot, which is pretty interesting. Do you have a lot of problems with waterproofing in those cases, Kino, or?
Oh, it actually comes with this, with the grease, when we grease the canisters up for the motors and everything. So the waterproofing was not an issue at all.
Like
the Treme Rex. No, go ahead.
oh, I mean, you said you were actually mounting a Vex components on your Sea Perch. Is that right? Or
Yeah, so we did some research. There's actually a robotic movable arm um that Sea Perch has, but you have to order it separately, right? So after we did the arm for the Vex, we did our research. We found a little robotic arm for that Sea Perch. They were able to get it mounting, and there were no issues at all. Just because I think what helped is putting together the arm for the Vex, where already had done most of our troubleshooting when it came time for the Sea Perch. It worked better that way than actually trying to do the Sea Perch first and then do the arm. Um, um, in regards that way. We didn't have any issues as far as blowing out the motors. Again, the hardest part with the Sea Perch was soldering the fuses. I was ordering almost two two controllers almost every 2 weeks for a while there, just because when it came to soldering, that's what the big issue was. So this year, in regards to the Sea Perch, I'm going to spend about 2 weeks just doing basic soldering um, before we even start putting together the controller for the Sea Perch.
okay. Um, thank you, Chris. I'm sorry, Kino. uh, so let's see. We still have a few people we haven't heard from. Rebecca talked earlier, but I don't think she had a chance to introduce herself. Would you like to say a few words, Rebecca?
Sure, I can do that. Um, my name is Rebecca Kraus. I teach at Patrick Taylor in Jefferson Parish. Last year was my first year teaching Intro to Robotics, but I've taught Intro to Engineering since 2017. Also teach AP Physics, AP Environmental, have an engineering background. In terms of advice that I would give maybe to new teachers, I think I kind of already said it, is kind of lean on the experts that you have in your room. Um, Also be, I think, intentional about your grouping with your students, because like I said, you're going to have students that have more coding experience. So I try to get like, an expert in each group that has that coding experience. I mean, I would definitely keep an eye out for the kids who like to tinker but don't like to code. Had quite a few of those. They took the class because they saw robots rolling around out in the hallways, and they're like, "Oh, cool!" And they like to come in and build, but they didn't really want to get into the coding or even the math aspects of the class as much. So, keeping on top of those students can be a little bit of a challenge. Um, I agree with whoever said earlier. I give my students a rubric at the beginning of each unit, and I make them responsible for keeping it. And I found, because I've been grading Intro to Engineering notebooks, like I said, since 2017, but I think giving them the rubric at the beginning of the unit, and then after each lesson is complete, I'm like, bring me your notebook with your rubric. That way I'm not left with this glut of grading at the end of the unit. I've kind of kept up with it as we go through each lesson. And so at the end, it's real simple. I just add up the points and I'm done. Um, Other than that, I don't think I have any other advice.
All right. Well, thanks for sharing with us, Rebecca. um, and we still have a few other people we haven't heard. We haven't heard from Lawrence yet. He's been quiet the whole time. So Lawrence, he almost every year I think you've had a team qualify for Worlds, right? So I'm sure you have some good advice for us.
Okay, yeah, my name is Lawrence Knox, and I am at Baton Rouge Magnet High School. Been teaching the intro class for about 4 years. Um, just listening to everyone talk, I mean, there's a lot of good information that I'm listening to, and it's a learning experience. Every day you learn something new, and um, yeah, every day there's issues, and every day, we're learning something new. So, yeah, just keep an open mind, and I mean, at the end of the day, what's done is done, and the next day's a new day. So we just kind of start all over every day. It seems like. But the LSU curriculum, it's good. I mean, we try to just follow it. And the resources are there on the shared folder. Um, all the tests and homework assignments are there, and that it really helps me out. Having all that information there at my hands, knowing what we're going to be doing next, and just follow it step by step.
All right. And any advice for the new teachers?
Yeah, I guess just what I do is I just try to follow the what's in the shared folder. I just start at unit 1 and just keep moving to the next unit, and then also the meetings that we have every couple months. Those are important to join those, and this meeting here too. I guess being off on the summer, I kind of just waking up, trying to get back into it, just keep my mind on it.
Okay. All right. Well, yeah. Thanks, Lawrence, for sharing with us. Let's also hear from. Well, we haven't heard from Raven yet. Would you like to say a few things, Raven?
Oh, sure.
Thank you, Lawrence.
Hi, everyone. I'm Raven Winchester. This is my first year teaching, and also I am teaching all 4 classes. So Intro to Robotics, Intro to Engineering, EDD, and Intro to STEM. I am a bit overwhelmed, but just hearing everyone talk. Oh, also, I'm from St. James Parish, and I will be teaching at the Career and College Center. But hearing all of your advice, I'm kind of like Ashley. I'm coming to this kind of blind. I do have a background in pharmacy, so I know a little bit, I have chemistry background in math. But as far as engineering, I'm a tad bit nervous, but kind of like you guys said, take it day by day. I'm probably going to be doing a lot of learning from the students, and I just have to prep myself. I'll probably be prepping myself every night to teach these courses. So, yeah.
I'm sure it's difficult for you with trying to take all these trainings for all 4 of the classes all at the same time.
Yes.
I'm sure that's
Wow.
probably
It's a lot.
overwhelming. Yeah. Yep. But we'll try to work with you as much as possible, make sure it's all successful for you. So
thank you.
And you have a whole community here that you can kind of lean on too. So
I love that. Yes. Thank you.
Sure. And then we also haven't heard from Stephanie Jackson yet. I think it is Stephanie, right?
It's Stephanie.
Okay. Yep. Hey, Stephanie.
Hey. Because I didn't have any advice to give.
Oh.
But so this will be my 3rd year in the high school setting. And this past year was my first year teaching any of the LSU courses. I did the intro to robotics, but the boys that I had in class only had 4 because it was like kind of a later ad. And they've been in robotics since they were in 6th grade. So they knew way more than me and way more than an intro class. So that was a struggle to keep them
Engaged.
Yeah. So hopefully this year, I think I'll have 2 sections and mostly freshmen. So hopefully that's easier.
And Stephanie's also one of our big robotics coaches in the VEX sphere. Do you have any advice for anybody that wants to start like a new team or anything? Or
I don't know that I can call me big. I coached middle school for a couple years and then moved up to the high school. But it's just been easy because the boys I have done it for so long, they don't need me, And this past year was my first year to host a tournament, and that was a lot more than I thought it would be. But we're still thinking we'll do that again.
Yes. Yeah, I got involved in hosting state one year, and then they asked me if I wanted to do it again. I was like, let me take a couple of years off from that. And there's a lot goes on, and it's a really rewarding thing to host a tournament, but there is so much work involved in that. Yep. So
Hey, Eric.
yes.
Hey, for Raven, for as somebody who teaches 4 engineering classes, separate classes in a day, for robotics, I would say if you can get some large clear tubs, because since you'll have different classes coming in, one thing that has helped me is I have like 8 clear tubs that they can fit the whole robot in and all the parts. That way they don't lose their parts, and they're responsible for their own parts, and then they can put them up on a shelf at the end of class so the other classes don't mess with it. They can put the top on it, and it's kind of like sealed away from the different classes.
Okay.
And the other thing I would say is stay on top of grading. Like with the different classes, all the different classes, if you can kind of stay on top of grading, because if you don't, you'll go home one night and you'll have big things to grade from every single class, and that's just going to be a lot. So I would stay on top of grading, and I would try to schedule it to where like a big project from one class is not finishing on the same day as a big project from another class, kind of like stagger them so that it kind of makes it easier for you to grade.
Okay, thank you.
I think with that, I think we have actually heard from everyone in here. Is there anyone that I missed? So we saved the best for last with Stephanie, right? So, and of course Raven. Yep, we had our best new people and our best old people there. I'm not calling Stephanie old. So we're trying to wrap up around 10 o'clock. We have about 15 minutes left, but we could either wrap up early, or we could maybe open this up for any sort of is there any sort of discussions either about the classes or about maybe just robotics in general, like, or maybe some team discussion or anything like that, if anyone's interested in forming a robotics team. I have a decent amount of experience with that, and we also have quite a few veteran coaches on here too. So if anyone's interested in anything about like the robotics team and how the competitions works, at least because I think with what we have here, we have several VRC coaches, we have some C-Perch coaches, we have some FRC coaches, I think, on here as well. So we have a wide variety of experience there. So
I can help with any of the FRC
what is the
PC questions.
what is the best resource as far as website to use if I want to register? So what I'm looking to do is take a small group to a VEX competition just so they can see how it works first before we really get into it. I also coach, right? So I coach volleyball, basketball, and track. And with coaching, I try to give them that experience, where we can go to a game, watch first. So when it's our time, you kind of have an expectation. Because I know my school really wants us to get back to doing competitions again. And as I was looking at how some of those competitions were offered, by the time I was able to start signing us up, the registration was already closed, so a lot of those things start happening pretty quickly. So what's the time frame? What's the best way to go about doing it? And what are those resources that we can use?
And I assume you're asking about VRC, in this case, the VEX competition. Right?
Yes.
Okay.
Yep.
So the best place to find out about events that are going on is going to be robotevents.com. And that's also where you go to sign up for sign up your teams and to sign up for events. Like currently there's probably not any events really posted yet. I know I'm planning on hosting a VRC tournament and an IQ tournament this year, and I've kind of got the dates picked out, but I have to get approval from my administrators the auditorium. So I haven't put the dates in robot events yet. So I don't have it up yet. But that's where all the events will be. K Turner has more than 24 hours in a day.
I checked the website the other day, and there's no events in Louisiana for this year, as far as I could see, yet posted.
Yeah.
Robotic.
Didn't team registration normally do in November for VRC?
Yeah, the registrations are due by November. That's
what, 200 for the first team and like 150 for every team after that?
No, it is now
it went
just
up?
200. It's just 200 straight up for every team now.
Oh, is it? Okay.
Yeah. Yep. Prices just keep going up and up and up.
What are the individual events now? They used to be like 55 for most of them.
Oh, well, that's up to the individual host to set the prices for those. I think since the cost for like the field equipment is going up a little bit. Like I think for instance, like the field sets are like $600 per set right now. It and in the past have been like 500. Like I've usually kept it at 55 for a VRC event, but I'll probably go up to 60, I think, just to cover the extra costs there. But I'm not what I'd really kind of like to see is for us that are hosting in Louisiana to kind of get together and kind of maybe set some standards. Like for instance, I like as far as like with engineering notebooks, for instance, like you have the option of either doing a paper version or a online version, the digital, but you can't do both. You have to pick one or the other. And I think I think all the I think all the event partners should probably get together and I think we should just all move to digital. Now, honestly, it's not really super big deal because if it's a paper, you just have to remember to print it off. But
if the
everything's
national standard is that they need to be digital, then the state probably should at least move towards it.
Yes. Yeah, since Worlds is digital and State has been digital. So yeah, so we probably want to just have everything digital. And then also if we get together, we can maybe set like a standardized pricing and that kind of thing too. Also, if we could get together, it'd be interesting to share field elements with other event partners because, like for instance, because you really need 3 sets of fields at least to host an event, and maybe 4. Like, if you had 4 sets, you could have 2 competition fields, a practice field, and a and a skills field, which would be about the minimal you want. And depending on how large the event is, you might want 2 skills fields so you can run those concurrently, especially if you have like a 30 or 40 team event. So obviously one of those field sets you probably have as a practice field, but the other one, if you're only hosting one event, then you're buying like 2 or 3 extra field sets that aren't going to be ever used again. And so if we had a way of like coordinating and sharing between events and passing on the material, so like maybe if I'm hosting 1 week and then another team is hosting like in a couple of weeks, then I could maybe share my stuff with them or vice versa. That would be kind of interesting. So we wouldn't have to invest so much into stuff that's only going to get used 1 or 2 times.
One thing that would be cool is if it was kind of like a track meet where the timers come in, and so I don't have to pay for a timing system. I just pay a person to bring all their stuff and they set everything up, and then I'm responsible for managing the meet, but they're responsible for taking care of all of the scoring and everything like that. So I don't know if that would be something that anybody would ever be interested in doing, but you could have somebody who that was across the state who that was their job. They would go to the different venues and they would set up shop for that particular week and they would bring all of their fields, set everything up, and then run the scoring aspect of it, while the person who is the host would be the manager of the entirety of the situation, I guess. I don't know if that's doable.
There used to be, there actually used to be when I first started, like 10 or 11 years ago, there was a company that kind of did that. It was like Red Stick Robotics, and they went around hosting events. So like they would just partner with people and then just host, and they would bring in the judges and refs and all the equipment and do that. Region 5 STEM Center is actually really good about helping share materials and stuff in that region. I'm just like stuck in this northeast corner of the state, and there's really no other teams around our area, and so I just have a lot of trouble getting teams to show up to my events because they have to travel so far.
Yeah, you're 4 hours
my
away.
wife started. Yeah, yeah,
And
that's
what's bad for me about the
that's so
Region 5 STEM Center is they do their stuff during football season, and I'm a football coach. And so by the time I get done with football season, they're wrapping up their league and their season, and they're usually done in like the middle of November, and that's usually about whenever we're done with football and I'm available to start going to events. And so it doesn't really work out, unfortunately.
yeah, yep. But yep. So at any rate, so as far as like the prices go, you'll probably see the VRC events being around probably $60 event. I know there's some places in New Orleans that usually charge a little more. Like I think Holy Cross usually charges like 75 for an event. But usually like 55, 60. I'm pretty sure Alexander is probably going to still charge 55, but I'm not 100% sure on that. I haven't talked to DJ about that yet. And then like IQ events for like the little kids, I use the equipment's cheaper, so I usually only charge like $35, $40 for those events. But I don't think anyone's interested in IQ. That's still a far cry cheaper than FRC, though. But then there's also FTC. That's are there any FTC coaches here? So FTC is pretty much on. I would put the pricing level of FTC pretty similar to VRC towards Vex, as far as like the scale of the robots. But I think they get to use more custom parts than FTC, if I'm not mistaken. Yep.
You're
good.
I'm good. I can talk. Yeah. So the good benefit of doing both that I'm gonna sit down right here. If I can.
Here, I'm moving.
I'll steal it. So okay, here's kind of the difference because I do both when it comes to the classes versus our team at Denham Springs High School. So Vex, everything is very. You get a kit. Everybody has the same kit. They all have the same parts. They're using the same programming languages, at least in general. With FTC, you find a lot more variation. You can get a kit and just use that kit to build every year, and that's perfectly fine. And you can create some great robots. But you also have teams that are CNCing their own parts and they're 3D printing their own stuff. They are doing things like some of them program in Java, some use more of the block style code. You can get really, really in depth in the Java code because you are using customized parts, and sometimes you're using, custom encoders that you find and you want to use in the system. And so in some ways, while the initial price between the two tends to be comparable, getting your kit, by the time you get a kit that has enough stuff in it that you want, you're probably paying the same that you'd pay for a Vex kit. It can get more expensive, especially as you move from year to year, because you're like, well, now I want to add, 3D printing. And so you write a grant to get a 3D printer and you can print up all this awesome stuff and put it on your robot. It just really depends. The other difference is the scalability and the difficulty of competing against other teams. Because you can do those things, because you can make, custom drivetrains and things like that, you can start getting to the point to where you're competing against a team that's been doing it for 5 years. They have different materials than you do. And so it becomes more difficult to compete and get to that level. So it's kind of a positive and negative. I've seen some really, really amazing things done from our FTC teams. We've had one in the past. We went up to 2 recently. They went back down to 1, depending on the number of kids that are part of it. And I've seen them learn some really amazing stuff that, of course, I use. I'm an FRC coach. So we build 125-pound robots, 145-pound robots. And my budget, I'm not going to tell you because it's hard and it hurts. and it's painful. But
it's in the tens of thousands, right? Like
our budget. Okay, so again, we went to the World Championship and we made it to the top 8 teams in the world this year, which is really awesome,
really
and I'm
impressive.
excited for that. But my budget this year was $150,000.
Okay.
Which, yeah, that hurts my heart too. We have some great sponsors, and we're what's called a NASA House team. But that's just with our FRC teams. We have FRC teams that compete that are, talking about $20,000, $30,000. It's a different level of competition. What FTC allows me to do is to bring kids in their 7th and 8th and 9th grade year, and they can start working with the systems that we use when they make it to FRC. If a student was participating in VEX and I had them move up to FRC, they wouldn't have the same quality of spread of knowledge that I would need them to have because they were using a very delineated kit, right? But in the same sense, I have kids that never join my FRC team, never join my FTC team, that go through Intro to Robotics, and they come up to my Advanced Robotics class because they love building robots and they don't have the time to invest in the wide scale, like after school program. So I think really there's a place and a space for all of it. And I recommend teams. It's really about your budget and your time and the way you go for it. I said, I like FTC for that same reason, that I can bring FTC to high schools that say, hey, we want to use our 3D printers. We want to have them be able to use metal and things like that are separate from what's in a kit, but we just can't invest in the FRC. And for teams that are like, look, we're never going to have the 3D printers. We don't have time for that. We have a chemistry teacher or whatever that just has enough time to coach this amount. VEX works really, really well for that space. So it really just depends on what you're looking for.
Yeah. Yeah, because and on the VRC side, they're even kind of scaling back from custom. Because starting this year with the new rules, you can't even have custom license plate holders anymore. Like so no 3D printed anything anymore. Also, they changed some rules on the plastic now, the plastic sheet. Well, the plastic sheet rule, what they've kind of done is in the past, you could use like a 1 sheet of plastic, like a 1 by 2 foot sheet of plastic, and cut out whatever you wanted out of it. Now you're limited to 12 plastic parts from the plastic sheets. And each of those individual parts can be like, I think a 4 by 8 in size, up to a 4 by 8 in size. And so, but they're limiting how many plastic parts you have. And I think they're scaling back just to kind of keep the playing field a little more level, because they were seeing like a lot of teams using these like laser engravers, cutters, and all this custom plastic, and it was seeming to kind of cause like an advantage versus teams that didn't have access to that kind of equipment. I guess I think that was the reasoning behind it. But yeah, so like you said, so since it's more enclosed environment, then there's not. But it's a more level playing field because you don't necessarily have to have all this equipment to be successful. But then it also kind of cuts down on, like you said, for instance, the skills they can learn, like for there's a lot of skills involved in making your own 3D parts, right? And designing your own parts and printing this out and testing them out, and they kind of like walk that back on the VRC side a bit. So. Well, it is 10:02 right now. I said I would try to keep you guys on just for 2 hours. Is there any final thoughts anyone wants to share? I think this has been a pretty productive meeting. It's really important we get to kind of all get together and know each other too. Hopefully, I'll see most of you guys at the COP meetings when we start those up. During the school year.
Will we get email notifications for those? Like, how will we know when those are going on?
Yeah, Vanessa will send out. She will send out reminders for the COPs, and she'll set the schedule for those too. So you'll know the schedule like at the beginning of the year, like what dates they'll be on. Typically, there's like one a month. Well, there's typically 6 of them in total throughout the year. So typically there's 3 before Christmas break and 3 after Christmas break. And so, but she will set the schedule for that. And then usually the week prior, she'll send out, if she remembers she'll send out reminders on those 2 coming up. but you'll know the schedule ahead of time. And usually the COPs are usually like last year they were all set at like from like 5:30 to 5, but we didn't necessarily be on there till it was 3:30 to 5. But we didn't necessarily always stay the whole time. So it's generally just right after school. We'd have that meeting in the afternoon, and it was just a chance for everyone to kind of share any sort of issues they were having with what they were learning, or any things that they found out that they were doing that worked really well and they wanted to share it. That's kind of what those COP meetings are about. Yep. Okay. Well, if there's nothing else, I think we might wrap up for today. Now for the intro people that are taking the class right now, let me just look at the schedule. But I think today is just today's meeting. But if you're having any trouble with those assignments, I wouldn't mind working with you guys on any of that. If I can stay on for those intro people that want to. But once again, you don't have to. If you have other things to do. So for the intro people tomorrow, you guys are going to share your project, your sensor project, PowerPoint, not PowerPoint, but Google slide, your poster project. And then tomorrow we're going to be looking at the Unit 8 stuff. That's going to be our auto straightening. We're going to introduce loops and if statements. So we'll learn some more programming stuff tomorrow. And thank you for everyone that came on today. It's always good to see the old faces again. And I'm glad everyone got to share their experiences. So,
hey, and
Are you doing the advanced one?
It's the advanced class. Did you get an email for an advanced class?
I don't remember getting an email for that one, but I just didn't know what time to log on for it.
Yeah. I did not. In fact, I was asking David about that earlier. We could just stay on and talk about the events. Well, let everyone leave because I don't think Vanessa sent out.
Yeah, I didn't
events.
remember getting one.
Yeah, I didn't get one either, and I'm supposed to be leading it. So, but yeah, anyone that's doing the advanced class, we could just stay on a few minutes and talk about the events. Did David already leave? Because no, David's still here. Good.
Hey, if you're an intro person, I would say blow up Eric's email. That's what I did my first year. If you can't wait for the COP, just blow his email up. He does a great job responding to emails and helping you out. So
yes, I definitely got quite a few from Chris, but I was always happy to help him out. So
we're good to go.
Yes, you guys are good to go, unless you need something. Yep.
I'm gonna go build a bridge for engineering. So
okay, all right, have fun with that. But like if anyone wants to stay on and talk about advance, we could do that for a few minutes.
I actually
like for instance, David.
Oh, I'm sorry. I was just going to say I
Okay.
didn't get to teach it last year, so I'm supposed to have some kids in it next year.
I think I've mentioned this before when I've taught the advanced class to you guys, but I still have not been able to teach a class of advance. My school has not put it on the schedule. So I'm not even sure if I'm qualified to teach the teachers about it because I've never taught the class myself to students. So we do have a few people here. So Logan taught advanced last year, right? Or did you?
No, I did not.
Okay, no. Did Lawrence? Lawrence is still here. Did you teach advanced last year, Lawrence?
Yes.
How was your experience with that?
Well, when you taught the class, I mean, you pretty much told us we had leeway to use the curriculum. Like with the intro class, I follow the LSU curriculum step by step, but in the advanced class, I begin with it, and then I pretty much just let them work on their competition robots. And
yeah. And that's mainly what the class is for. but you can make it as structured as you want. If so if you wanted to, you can make it more structured and have like specific projects or skills that you want them to develop. And I think I think that's if you look in the advanced folder, that's what a lot of that is just some suggestions on some things to do. Like for instance, did you do any like CAD kind of stuff with them, like with OnShape or Inventor or anything like that, as far as like them designing the robots in CAD or?
Not really. I mean, remember when we took the intro class, you had went over it, and I struggle with it. Like, I don't know. I just remember we spent like 3 4 days on it, and we got a couple pieces put together on it, and it was more frustrating. And so, I mean, what the kids do, they use YouTube. I mean, they're
Mhm.
constantly on YouTube. There's some Discord they're on. I'm not sure about it. And you know the Vex forum, that sort of thing, and they're constantly just scouring the internet for ideas.
Yeah. Okay. Um. So, do you have any advice for like, for instance, David? Um, David doesn't have the benefit of like spending like 2 weeks in an advanced class, like like a lot of you guys did, like Stephanie, and okay. So see you, Logan. But so Stephanie, you took the class with us, the advanced class, but you haven't been able to put it in practice. So I guess you don't really have a lot to say about it. Do you want to tell David some stuff that we did in the summer class? What was it last year that we that you?
It was last summer. We did
Yeah.
OnShape. We did some programming. Um, I I think a lot of it was OnShape. And we learned some coding. I still struggle though, because like in that class, we did C++. And then the stuff in the intro class also, if you use text, is C++, but everything veers Python. So I don't understand why that.
So
Like,
what is OnShape? I'm not familiar with that.
it's
say
an
that.
online CAD software, and it's confusing. But I mean, like, but it has all of the Vex parts in it, and so you can basically build the robot. My
Oh,
boys that I had, you liked Protobot, and they
Yeah, that's
already
another one.
started using it on their own, so they used it all year and they liked it.
okay.
Yeah, there.
Protobot.
Yeah.
Yeah. So
I think
OnShape is
that the
just like
Protobot you have to download. OnShape
yeah.
is online.
Yeah.
Okay.
So OnShape is just it's a it's just a CAD package, but it's online. It's browser based. And you can have a free student account on it. Um, and it has the Vex library of parts in there. Like you can pull up a Vex library, has all the parts, and so you can just kind of like mate the parts together, and kind of build your robot. I'll show you what it looks like. It's going to be very slow on this Chromebook because this Chromebook
I'm driving right now, so
is
I'm not
not.
really looking at my screen anyway. So
Oh, okay. Yeah. Okay. Well, never mind then, because I was trying to pull it up and it was like super slow on this Chromebook. But my teams use it. At least my senior team. In fact, they've already started designing stuff for their new robot this season. They've been throwing some designs together in that. But yeah, but OnShape's not the only thing out there you can use. So there's a lot of like you can use Autodesk Inventor. You can use Protobot. I think there's a few other ones out there. It's just the nice thing about OnShape is that it's free, and that you can do it even from a Chromebook, because it's all browser based.
okay.
So those are
You
some.
mentioned a few minutes ago. I've got kind of a offshoot question. You mentioned stuff about the engineering notebook in reference to the competitions, do teams have to turn in an engineering notebook at competitions or something like that? Is that part of the process?
Yes. Yes, that is part of. I mean, you don't have to turn in an engineering notebook to compete, but you're not eligible for certain awards unless you submit an engineering notebook. So
I will say the 2 times in my coaching history in middle school that we've been to Worlds, it was a notebook. It was a design award. So a notebook itself can take you there.
yeah, actually, we qualified for Worlds this year off the notebook with the design award. Yep.
So what all did y'all have in there that was impressive or whatever? What is it? What does a world class engineering notebook for VEX competition look like?
There's actually digital templates on the site. Robot events, I think.
Yeah. Yeah. So if you search, I don't think it's probably on the REC Foundation site. But if you search for like VRC engineering notebook template, you can. There is a notebook that my teams kind of use as a model. Like one of the teams that won design at Worlds posted their notebook. So you could kind of see what they did. And it's a really impressive notebook because it's like, it's hundreds of pages and they've kind of document like everything. Like they have everything from their builds. They have like all their testing data, like so they have all like these data tables from when they were like testing different systems. They have like all their code in there. They have like their budget, their timelines. They have like decision matrices for designing like what kind of components they're going to use. It's pretty impressive stuff. There is also if you want to look up the way the judges score that, you might want to look up the judges handbook because there's a scoring rubric for notebooks and also a scoring rubric for the team interviews, and you can kind of see what the points are on there, like what should be included in the notebook. But the big focus on it is making sure that the engineering design process is documented, and also that they're going through multiple iterations of their robots and going through that engineering process. That's a big part of it. Yep.
Okay, that's cool. I didn't realize that was a component of the competition. I haven't had that time yet to read through the game manual or anything like that yet. So
yeah, so at each tournament, there's in addition to like say winning tournament champions or skills champions, there's also several judged awards. And for instance, the top award at an event, the excellence award, it actually takes into account like all those situations. Like you have to be like I think you have to be like the top 20% in skills. It might be 30%. But top 20 or 30% in skills, top 20, 30% in programming skills. You have to be in the top 20% in the qualifying rounds. And also you have to have like be a contender for like winning design for engineering notebook. So there's a lot of criteria to be able to hit that excellence award, which is that top award that you give out. And there's other awards too. There's the design award. Recently, they've added this Innovate Award that's only available if you do an engineering notebook. And then there's also a lot of optional awards that can be given out at competitions that you don't see very often. But there's several other judged awards that can be given out at an event as well. Yep. So yeah, it is an important component to it. I remember back when we first started, my kids kind of ignored the engineering book the first couple of years. But they didn't really start getting successful until they started like, actually doing the engineering notebook. Yep.
Yeah. So the way that I'm at least theorizing that I should set up my class for advanced robotics upcoming is I'm going to divide them into committees. And so my plan was to have a documentation and planning committee, and their responsibility was going to be both doing the engineering notebook and things like figuring out how to get to the competition, quoting out, buses and hotels and stuff, whatever we need to do. They're going to plan the field trip, not me. And so it sounds like they'll have their own competition component as well. So that's a good thing. That makes me feel better about having that group and not them not being, because I was worried that they were going to feel like they weren't part of the action at the competition. But it sounds like they'll get an award just as likely as the other ones.
Yeah, and even at the tournament itself, there's a lot that well, for one, the judges interview the teams, but and one of the things I kind of look for is that everyone on the team is speaking and having some sort of role in the interview. But there's, even if they're not like say driving or maintaining the robot, there's a lot of roles they can do. There, like for instance, scouting is actually a big deal. So them watching matches and seeing the strategies other robots are doing, seeing what their autonomous strategy is. Because one component of it is like alliance selection. So so once the teams play through their qualifiers, then the top seeded team can pick an alliance partner to go into eliminations, and then you kind of work down by seed until all the elimination alliances are filled up. And so getting an idea of who would be a good partner, because it's not always necessarily like one of the top rated people. There's a lot of strategy involved in that. So for instance, there might have been a team that didn't get really high in the seed because they had a bad match or someone broke on a match and that kind of dropped them down. But maybe their robot complements your team's robot really well. So you might want to pick them even though they're lower down on the seed. There's other also strategies, like maybe you pick an alliance partner because you want to break up a potential alliance of two other teams. That's a strategy that's sometimes used. I think Lawrence has run into that before sometimes. Yeah. So
yeah, the kids, they have their own strategy, and they can never even predict what's going to happen, like things happen and they have to adjust. Like last year, was it that team went down and asked a bunch of teams and a bunch of teams said no? Then what? You know what I mean? It's like, then they have to adjust. If they don't know how to adjust from that, then,
Yep. But so David, there's a lot of aspects that are good at a tournament, and so but yeah, that engineering notebook component is really important. So like I would probably provide in the class, I would provide the kids with that rubric early, that engineering notebook rubric, and kind of make sure they're kind of following that, and you can make that a part of their grade component for the class. What their engineering notebook's like, for sure, and because you already have a ready-made rubric that you can kind of base it off of. Same thing. They need to know the rules really well, because one thing, since it is a student-centered competition, the teams have to advocate for themselves. So, like if there's like a rule violation or a scoring issue, they have to be speaking with the head refs themselves. So you don't have like coaches or parents like stepping in to advocate for the kids. They have to advocate for themselves. And so it's really important that they know and understand the rules and can also like explain and point out rules when they need to. So that's always that's another important.
I was gonna, one of my other committees that I was gonna put together was game strategy. So I was gonna have a group of kids, probably some of my like football players who are used to watching film and talking about strategy, because that's a big deal at Central High football. They watch tons and tons of film of their games and their opponents' games and talk about strategy constantly. And I mean, it paid off. We got state champs this year, or last year. But so I was gonna get some of those guys to be my game experts and really dive into the book and plan strategically for what are we gonna do in the game, what pays off the best, do the math to figure out which attack, which scoring method is going to mathematically work out to us getting the highest total points.
Mm-hmm. And that's like my most successful teams that always had members that have like just gone on YouTube and watched matches and analyze matches, and and also analyze the scoring. Like for instance, for this last season, there was this big square ladder that was in the middle of the field that was mostly ignored the entire season, simply because most of the kids, when they kind of did the cost benefit analysis of building something to climb that ladder and the time it would take to do it, versus because the time you spend climbing that ladder is time you're not spending defending your other mobile goals from getting like maybe negatively scored. And it just wasn't really worth the time to do it for the most part.
Yeah, I noticed that watching a bunch of I watched a bunch of videos last year. I was nobody is climbing the ladder.
Yes.
And I didn't understand it because it was worth 30 points or something like that. But they did a cost benefit analysis and figured that out. That's cool.
Yeah. Because because what ended up happening is like if he had a full stack of rings and it somehow ended up from a double corner to a negative corner, then that's like how many points is that? Like that could have been like a 21 point swing right there.
Yeah, I mean it's even what is if you took it from a positive and threw it in a negative, that'd have been 24 points.
Yeah.
Because you got 16 turns to -8.
Yep. So a lot of teams just didn't think it was worth it. And in fact, what you notice is like over the season, the game manual, they started adding more and more incentives to the game manual for climbing. So like they were adding like some different bonus points. They adjusted the protected time. Because I think originally it was just like 15 seconds, right? And they extended that time.
No, I think it was. Yeah, I think you're right. What was it?
Yeah, I
30
think originally it was 15 and then they moved it up to 30.
Yeah.
Yep.
But there was a lot of movement going on at 30 seconds.
Yes.
Like at Worlds, and State, they would leave it at 32 seconds. But at Worlds, if you left it at 30.5 seconds, they would still take it out. And before it said 29, and there was a lot of, at Worlds, they were climbing the ladder. I mean, we were in one match where both our teammate and the opponent climbed at the top. But then even those like 229V teams who won their division, when it came to the dome part, climbed the ladder to the top and fell. And that was it. It was over for them. They didn't advance to the whatever.
Yep. So yeah, and that was another thing about the climb this year. It was not only the cost benefit of points, but also what happens if your robot falls from 4 feet up and you break it. That's why you didn't see it as often in qualifying matches, because they just didn't want to take the risk of breaking their robot and being out for the rest of the year.
That could climb, they chose, if they thought they were going to win the match, they chose not to risk it.
Yeah. They kind of saved it as their trump card, basically. Yeah, and so in this game too, it's still so early in this year's game to really say how things are going to work out. I don't know what the meta is going to be for this year yet. I think it's still kind of too early to say. Um, uh, I've seen some matches from some Asian teams have already been posted, and then there's been a lot of early builds posted.
You saw those matches what on just YouTube?
Yeah, yeah. There were a few on there. Um, and but even those bots were kind of like you could tell they were kind of early build bots. So I don't think that there has been a meta established yet, but I'm sure it won't
And
be too
it's
long.
constantly changing, right? Like
Yeah,
in August it's one, and then November, December, and then January, February.
yeah. But that's one neat thing about the VRC is how it evolves over the course of the season. Yeah. So you're kind of forced to evolve with with the game if you want to stay competitive. Yep. Um. So, but yeah. So David. But it's kind of the advanced classes. It really is kind of up to you how you want to structure it, though. So um, just whatever you think. So with your committees, do you have any idea like how many students are going to be in the advanced class, or?
So I think I'm gonna have it. I'm gonna have probably more than 10
Okay.
in the class. I think I'm gonna have somewhere on the order of 12, but I'm not positive on that. So the committees may be one or two kids, or maybe because I'm still kind of forming this idea in my head, and I need to reach back out to our counselors and see like, okay, guys, I need a roster. I need to know who's in my class so that I can start putting together a plan for the team.
Mhm.
So the ideas are still kind of in their infancy.
Yep. And as far as teams go, I mean, are you just planning on having just one team, or are you going to try to have multiple teams, or?
This year, yes. This year, now I'm going to allocate 2 brains to the team.
Mhm.
I have a certain number of brains, and so I'm going to allocate 2 to the team so that they can build 2 prototypes,
Yeah.
and we can alternate between them. But I was planning on like having one robot or one team on the events registered. Mostly just because I don't have the finances to my finances are extremely limited. So
Yeah.
registering a second team would be expensive. And also I like the idea of the unity of everybody's one team.
Mhm.
Yeah.
Okay. Yeah. So I think you'll probably be fine. And once again, if you run into any problems, you can reach out to any of us. And we'll, especially us more experienced coaches, we'd be happy to help you out.
Appreciate that.
Yeah. Well, how about we wrap up here? Sound good? Unless there's someone else that we want to talk about.
I had a couple questions.
Oh, okay. Sure.
What school, Stephanie? What school are you at?
Sulphur High.
Sulphur? Okay.
Mm-hmm.
And on the intro class, Eric, did you say that it's gonna be different in terms of like the shared folder and like the way that things the LSU does it?
Uh, yeah, but that won't be until next year, like not this coming year, but they are going to eventually move everything to a learning management system. Um, so like the students will be able to log into that, and they'll be able to post all their assignments there, and you'll be able to see all their student work and everything through that system that they're going to have set up.
But in 25, 26, it's not going to be different.
Yeah, they just weren't ready to roll it out this year, so.
But like, are the assignments going to be?
It should be the same work. It'll be all the same assignments and everything, but it'll just be a different method of turning it in, basically.
Oh, okay.
Yep.
I usually just print them out and hand it to them.
And yeah, I'm not sure about that standpoint. I think they will probably try to translate those paper tests into some way so you can just assign the test through the learning management system. I think is what they're going for. Okay. So that everything can just be contained in that system.
She said they are going to try it in Intro to Engineering this year.
Yeah.
So
yeah, Intro to Engineering.
They're trying to do it in ICT as well, in the Python version of ICT.
Mm-hmm. Yeah, but well, for one, they need people to be able to translate all the content into the system. Vanessa actually asked me to do the robotics last year. I just didn't have time to do it, so I'm wondering who she'll get for that. She'll probably get Catherine Coates, maybe. But we'll see.
Oh, she works for them now?
I think she did. Didn't she move over? I think that's what I heard.
I guess that's the new lady that was there, huh? That's who took it. The Ashley Fontenot, Haynes Academy.
Yeah, she took over for she took over for Catherine at the school.
And Catherine's with Vanessa now?
I think so, but I could be wrong. But I think that's what I heard. Yep.
Okay.
Yep. Yep. Well, all right. Well, if you guys have any other questions, you can also email me at any time too, and we can even set up another chat or something if you guys want. So, but it's really good seeing everybody again. I'm always happy to work with my fellows. So,
did you say you're trying to host a VRC tournament this year?
Yes. We will be hosting a VRC tournament this year.
Okay.
And it's probably going to be, it's either going to be in late January or early February, I think. That's the time I think we're going to try to do it.
Okay. If you end up needing a field, let us know.
Sure. I'm going to keep that in mind for sure. Okay. All right.
Okay. Well, y'all have a good summer.
Yeah. Take care, everybody.
Y'all too.
Yep. Bye.
Bye.